Hello everyone. So in this video I've taken a look at some shapes that kind of look similar but I've got different names for them. So take these three, of course. Now they're all oval in shape, so a general oval is basically a rounded shape, no straight edges at all. So a circle, technically an oval, but we call it a circle. An ellipse, how's that different from a circle? It's kind of like a stretched circle, but it's still an oval. This one here doesn't fit either of these two, okay? But those are three generally different shapes. Now in terms of the circle, how do you define a circle? Well, it's a locus, which means a general rule given to a particular thing like this. Draw locus all points that are a given distance from a given point, so choosing A centimetres, it could be 2 centimetres, 3 centimetres, it could be 5 metres. But I've got a point here, I want to draw all the points that are a fixed distance about that point. So to illustrate that, I'm going to use this here. This is what's called a pair of compasses. I'm going to put the compass point right on there. And then I'm going to adjust this to whatever I see fit, whether it's 2 centimetres, 3 centimetres, 4 centimetres, whatever. Okay, now that distance is fixed, and I'm going to draw a circle like this because all the points on that circle are obeying the rule. They're always a fixed distance from the central point. Of course, we call that the radius. So that's what a circle is. You can't do that with an ellipse. Okay, so ellipse is defined differently. With an ellipse, you've got what's called focus points. So there's two of them, one here and one here. And the idea is that if you have two fixed points here, then the distance between this point and that point and this point and this point, the sum is always fixed. Okay, so that and that, it's always exactly the same. Okay, I can demonstrate that for you. And right now, I'm going to insert a little video that shows you how to draw an ellipse. Here we go. So what I've got here is a makeshift couple of pins with a piece of string. So notice the string is a fixed length. Okay, I've tied it tight so it won't actually move. So it's a fixed length. What I'm going to do is I'm going to put a pen here, you see, and I'm going to try and keep the string taut. The difficulty is not getting it outside of the pins. And then just try and pull my fingers far away as possible from these two pins. You can kind of see that the path my finger is making is an ellipse. Now I'm going to have a go with the pen. So here I've got one go at this, because if it doesn't work, I've got to basically do it again. Here we are. So I'm going to put my pen here, see, and then I'm just going to do it in a anti-clockwise manner. So here we go. Just draw it slowly. Just make sure, yep. There we go. I'm trying to keep the string taut as I go around, so there's no slack. As a perfect ellipse, it will be such that the string's taut all the way along. Because the key thing you see is that it's always a fixed length. So obviously between the two focus points and then this and this is always a fixed length. And if I've done it perfectly, it will join up precisely here. There we go. Let's take it away. That's our ellipse. I'm pretty pleased with that, to be honest. Yeah, that's my moment of the day for me, drawing almost a perfect ellipse. I promise that was one take as well. Okay, so you got that. So back to this then. So that's how an ellipse is defined. And when we draw it on a graph, it kind of looks like this. Okay, so imagine that's the horizontal axis, the vertical axis, and then that's the center point of the ellipse. Kind of looks like this. So those distances there, they're pretty important. But that's what an ellipse is. Okay, but notice that the oval cannot be drawn in such a way. It's kind of like an oddly defined shape. Okay, it's kind of being drawn in some sort of random way almost, but there's no straight bits to it. Okay, now I've just overlaid a rectangle on all of those just so you can see the differences between them. So here I can fit a square around the circle such that the edges of the square are tangent to the circle. I can't do that on an ellipse. Okay, you can only manage it with a rectangle. Just to give you an idea, an ellipse is a stretched out version of a circle, just as a rectangle is effectively a stretched out version of a square. Of course, a square can be a rectangle, but when we say rectangle, we generally mean it to have one side longer than the other. Something about that coming up later on. Now with the oval, I've done exactly the same, but if you just notice these gaps here, they're not evenly distributed, are they? With an ellipse, those 4 gaps, they'll be exactly the same in area, but with an oval, something like this, they're not the same. Okay, just gives you an idea of the differences of these shapes. Getting back to what I said, now, you might have heard of the word oblong before. For years I wondered what the difference was between an oblong and a rectangle. I suddenly thought, well, there must be some reason why one's called an oblong, one's called a rectangle. And there is. Basically, a rectangle can be either a square or one in which the two sides are longer than the other. Okay? With an oblong, it's always this case. An oblong cannot be a square. Okay? An oblong is such that one of the pairs of parallel sides is definitely longer than the other. Okay? So that's the difference between an oblong and a rectangle. I just thought I'd throw that in there because I'm talking about different shapes. This, for many, many years, I wondered what this shape was called, and I finally got it given to me by a colleague of mine. Okay? It's called an ob-round. Okay? I kind of liken it to an athletics track because I'm kind of partial to athletics. So with an athletics track, you've got this straight bit here and this straight bit here, and then you've got the curved section, which you can imagine is like two semicircles that's being pushed together. That's effectively what one of these is. So you've got a straight bit here. Because of the straight bits, it's not an oval. You cannot call it an oval. And also because of the curved bits, you cannot call it a rectangle, an oblong. Okay? But what it is called instead is an ob-round. Okay? I just thought I'd throw that in there because it's kind of nice to know what the name of that shape is. Here, you can actually define it using locus. Okay? Draw the locus of all points that are 8 centimetres from a straight line. So 3 centimetres, for example. So look, I'm just going to put a few points here. So those points, they could be all a fixed point, that a fixed distance from this straight line here. And then equally, underneath, you could have these bits here. I don't know, it could be 5 centimetres, 5 inches, whatever. Okay, it's always a fixed distance. Right? As soon as you get to the end, you've got to draw an oval, kind of like a semicircle, really, from those points. Okay, and if you did it accurately using a compass, it would look more like this. So that's kind of what that is. That's what this is about here. This would be essentially the radius of this semicircular bit here. Okay, I'm hoping that you found all of that interesting. Here's just a summary of these different shape names. Okay, yeah. Thanks very much for watching, and I'll see you again.